Christine, and this is problem 14.1.25-T. So let's take a look. The data represents the heights and weights of a random sample of professional baseball players. Complete parts A through C. Okay, so we're asked to draw a scatter diagram of the data. So we're going to go in here. Let's see. And then here we have players, the height and weight. Okay. We're going to open this in StatCrunch. And then what we'll do is we'll go into the graph option and then scatter plot. And then the height and weight will be our y variable. All right, so this is what it looks like. And then, let's see. So we're going to be comparing this to the graphs over here. So let me go ahead and count on that. So, these are sometimes so hard to tell. I usually have to make them big. Oh, it's looking like this one. Yeah, because those 3 dots. And I don't see that over here or here. Okay, so let's cross our fingers. Perfect. And by the way, you can always blow these up too, so and more if you want to. So perfect. Okay, so determine the least squares regression line and test whether there is a relation between height and weight at the 0.05 level of significance. Okay, so first we have got to, let me clear that out, and we'll go into stat regression, simple linear, and then height is our independent variable, and then weight is our dependent y variable. And then we are going to compute that. And this is asking for the equation, and we can see the equation right here. So our slope is this value, 4.0578, and so forth. And that is being multiplied by the height. So that is our x value. And so 4.058x, that looks good to me, minus 93.9. Okay, so that looks right on track because that is our intercept. And it's negative and it's rounded. Perfect. Okay, so it's A, not B. Perfect. Okay, and then state the null and alternative hypothesis. So we're always looking at the beta 1, which is the slope, and if that equals 0, that's the null, that beta 1 or the slope equals 0. And then the alternative is that the slope, or beta 1, does not equal 0. All right, and then determine the p-value for this hypothesis test. So we look at the p-value for the slope, and that's 0.035. Oops, 35. All right, and then, so now at the 0.05 level of significance, we have to choose the correct answer below. So 0.05, so our p-value is smaller, so it's down in the tail. So it's away from the middle of the data. So reject the null hypothesis. There is sufficient evidence to conclude that a relationship exists between the height and weight of the baseball players. That's it. All right, and then remove the values listed for player 4 from the data table. Test whether there is a linear relation between height and weight. Do you think that player 4 is influential? Okay, so let's take a look at the spreadsheet. And here's player 4. And this, you can just delete the row. And now we just have 1, 2, 3, 5, 6, 7, 8, 9. And then we want to compute the regression, simple linear. We're going to have to choose the height for the explanatory and then weight for the dependent variable. And then let's take a look. So the p-value, look at that, it's 0.068. All right, and so when we see this, so when we remove player 4, the 0.05 level of significance, well, this is bigger, so we would not reject the null. And that there is not sufficient evidence to conclude that a linear relationship exists between the height and weight of the baseball players. All right. Do you think that player 4 is influential? Absolutely. Player 4, once we removed player 4, we rejected the null. And prior to that, we saw a linear relationship with the data. So perfect. So thanks so much for watching, and feel free to contact me anytime if you need my help. Have a great day.